So here is our 3D model which I have created in Solidworks version 2014, and it has initial cracks, as you can see here, in the 20mm diameter hole. Now I have imported the geometry in the static structural analysis. Then I have initialized the model right here. So now what we are going to do first here, we are going to create a coordinate system. We are going to go to insert and then go to coordinate system and then open, and then select the inside edge of this crack. Apply, click. This is our first coordinate system, and then we're going to create another coordinate system. For that, we are going to select another surface, another edge right here. We're going to click and apply. So basically we have created two coordinate systems. Now we are going to go to mesh and go to insert and go to the sizing. In this portion we are gonna select all the 8 edges of the crack. Like this, we are selecting all the edges of the crack. Here, and now click apply, and there all the 8 edges have been selected. Now go to the element size and select number of divisions. Now if that means how many divisions you want to divide this crack portion. For that we are gonna select 20, and this whole portion has been divided into 20 number of portions. So after that we are going to click mesh and go to mesh and click the method, which now I will select this whole body and click apply, and select this and then select tetrahedrons for the method of the mesh. Then select generate mesh, and it will generate this whole mesh. It will take some time. So here you can see that our mesh has been created. This whole crack has been divided into 20 number of sections. So then after that, what we are going to do, we are going to create a name selection portion here, and for that we are basically going to select this internal edge right here and click apply. This is our first name selection, and then we will create a selection and create a nodal named selection element. Then again we are going to create another name selection element, and we are going to select the other edge of the internal crack. Right here we have created another name selection, and we are going to create nodal name selection. Now after that, click insert and go to the fracture portion. Now in this fracture portion, what we are going to do here, we are going to click insert and go to pre-meshed crack. For that we are going to select selection 2 of the name selection, and again we are going to create another pre-meshed crack, and we are going to select selection number 4. So after that, what we are going to do, we are going to create a fixed support at the bottom portion of our 3D model. We are going to select this face and apply, So this is our fixed port. Then we have to apply a force of at the top portion of the surface. For that we are selecting this, and then we are going to apply 1000 Newton force at the top portion and just change its direction by writing minus 1000 newtons, and its direction has been changed, as you can see here. So after applying fixed port and moving port, let's go to the solution section and click insert and go to the stress. Here you will see the stress intensity and the total deformation. Go to the total deformation section, and then for strain energy, go to the strain energy section. Now after that, go to click and go to the fracture tool. Now in this fracture tool, we are going to select our pre-meshed crack first, and then click insert and go to the T stress value. But before that, go to the analysis section, analysis settings, and select this yes portion. And now T stress is bolded. Next again, create another fracture tool and select the pre-meshed crack number 2. After that, click fracture tool insert and T stress value. Now everything is ready. So let us run this, solve this whole simulation. It will take some time. So now our simulation has been completed. As you can see, the stress intensity value is maximum of 19.605. Right here at this portion. Now we will animate this whole section, and you can see maximum stresses are being generated in the crack portion. We will stop this and then select total deformation, and the total deformation value is 0.003015 millimeters. Go to the strain energy value, and this will show you the maximum and the minimum strain energy values. Those are in millijoules. And now go to the fracture tool, which will show you the static structural stresses values in the crack portion, and this is the T stress value, which is being shown here at this portion. So this was our whole analysis, in which we have calculated the strain energy and the stress intensity values and the total deformation. We can similarly change the force value right here. We can choose it to be 2000, and then again solve this whole simulation, and this will change all the results. Now after applying 2000 Newton force, the stress intensity value has increased. That means it is now 39.209 maximum. So this was the whole portion in which we have calculated the stress, strain energy values and the stress intensity values during crack analysis. So thank you very much for watching this.